Hello everyone, welcome to Setco College online classes. This is where we discuss all things mathematics, science, accounting and engineering. So in this video we're going to introduce exponents, where we're going to talk about laws of exponents and how we can deal with set equations, sets, and also how we're going to deal with exponential equations. So without wasting any more of your time, let's get to it. Exponents. So here with exponents, there is a bit of laws that govern these exponents. So to understand this topic, you should know a squared number is the product of a number times itself. So exponents, normally when we talk about them, you will notice also that we're going to talk about scientific notation. We are going to talk about the scientific notation. We are also going to talk about laws of exponents, the laws that govern these exponents. We're also going to talk about the squares. We're also going to talk about the square root, the square root. We're also going to talk about a cube and a cube root. Okay, we're also going to compare and represent numbers in exponential form. So we're also going to talk about exponential form. So basically that's what we're going to talk about when we're dealing with exponents. Exponents. Okay, so a square is a number with two identical factors. For example, if I say 4, I can rewrite this as 2 times 2. If we look here, we are having 2 and 2. These two, they are repeating. So if you look at it, 4 has two factors that are identical, which makes it a square. Okay. Then we can also rewrite this as 4 is equal to 2 to the power 2. Okay, we also have cubes. A cube, if we say a square is a number that is multiplied by itself twice, then a cube, it has to be 3 times. For example, if I have 8, I can rewrite 8 as 2 times 2 times 2, which is the same thing as saying 2 to the power 3. Okay. Now, just to give another example, we can write also 27. 27 is equal to 3 times 3 times 3. So these are 3 identical factors of 27, which you can now rewrite as 3 to the power 3. Okay, now let's talk about square roots and cube roots. Finding a square root, a cube root is the direct opposite of finding squares and cubes. For example, we started with 4 and we said 4 is equal to 2 times 2. Now, let's say they give me 4 and they say find the square root of 4. Remember, this is the square root sign. There is a 2 there, but we normally don't put it simply because we know that it's going to cancel out. So we are going to have a 4 there. So we know that this is the same thing as saying 2. Because how do we know that this is 2? We know that we can rewrite this as 4 square root of 4 is the same thing as square root of 2 to the power 2. Now we know that the square root and the 2, they are going to cancel and we end up having the 2 there. So it's very simple. We can do the same thing with 16. 16, the square root of 16, we know this is going to be 4. So take a moment and using the same method that I used up there and see if you can come up with 4 as the square root. Should be simple because you know that you can rewrite this as square root of 4 to the power 2, which is exactly the same thing as 4. Okay, now you can pause this video and try and find out if the following numbers are cubes or squares. So here are the few numbers that I'm going to write for you. We have 81, we have 64, we have 125, we have 216, 144, 144 and 289. So try and figure out if the following numbers are cubes or squares. Now let's talk about the square roots and cube roots. These are easy, but let's just go a bit in detail to find out what's going on. Now that you have noticed that you can calculate squares and square roots, you can find cubes and cube roots. Let's talk about the exponential form of these things. Already I've introduced you to it. For example, when I say 2 to the power 3, this number is in exponential form. How do you mean? We know that this is a base and this is the exponent or the power of this number. So this expression, we say it's in exponential form, or we can represent it as an exponential form. So you will notice that the other numbers, we're going to give you them as decimals or as fractions, and we'll ask you to express them either as positive exponents or as negative exponents, depending on what the question needs. Okay, so exponential form, any number that can be written as a repeated multiplication of another number, it can be written in exponential form. E.g., let's use the 8 that I already gave you, 2 times 2 times 2. We can write this as an in exponential form as 2 to the power 3. We can even have, let's say, 1000. 1000, we can rewrite it as 1000 is equal to 10 times 10 times 10, which is exactly as saying 10 to the power 3. Okay, other numbers can be represented in many ways. For example, we can have, say, 81. 81 is the same thing as 9 times 9, which is exactly as 9 to the power 2. But we can represent this number as 3. Sorry, forgive me there. We can represent this number as 3 times 3 times 3 times 3, which is exactly the same thing as 3 to the power 4. So depending on what you're solving or what you're given, you will notice that you have to develop a skill of learning how to deal with these numbers. You'll notice that when you're dealing with a certain problem, dealing with 9 times 9 is going to be easy, but also you notice that another problem will need you to deal with 3 to the power 4, just to simplify the problem that you'll be working with. Okay, so depending on the problem you're working with or you're dealing with, you have to choose a proper or a right method to suit your problem. Also note that in general we can express exponents in the form of a to the power b, where a is our base and b is the exponent. So this is the general form where we can write our exponents. So now let's look at some of the laws that govern these exponents. Already, if you have done your grade 10, and if you're in grade 10, this is new to you, but welcome to the world of mathematics. So you understand that a to the our very first law. So the very first law or rules that we're going to follow when we're dealing with exponents. You notice that a to the power 0 is equal to 1, provided that, or given that, a is not equal to 0. So a cannot be 0, because whenever a becomes 0, 0 to the power 0 becomes undefined. So it's an undefined number. So every time when you're dealing with exponents, note that a, if it is your base, it is not equal to 0, because that particular problem becomes undefined. Okay, so that is our very first law. How do we use this law? It's simple. Any number, take even a million. So let's just assume here I've got 200. 200 to the power 0, this will give me 1. It doesn't matter how big the number is. It can be negative as well. Minus 10,000 is still going to give me excuse me, it's still going to give me a 1. When I have it minus 10,000 to the power 0, it's still going to give me a 1. So it doesn't matter how big the number or how small is the number, as long as it's raised to the power 0, it's going to give us 1. So that is the very first rule, which is very simple. Now let's look at the second rule. The second rule says if we have got a raised to the power m multiplied by a raised to the power n. Things to note here. This exponential has a as the base, and this one also has a as the base. So if we have got the same basis and we are multiplying, this law simply says we are going to say a to the power m plus n. So if we're going to have exponents of the same base, what we're simply going to do is going to add the exponents or the powers. Okay, things to note here: a is still not equal to 0. Remember that m and n are also whole numbers. M and n, in this case, they are also whole numbers. Okay, m and n are whole numbers. Okay, note that the base of m and n is the same, which is a. The base of m and n is the same, which is a and a in that case. Now, let's have our law number 3 or our rule number 3 that govern these exponents. If we are multiplying here, so it means we have also to talk about division. So a divided by a to the n, let's have our m there. So in this case, it's going to be easy. We already know that if you are dealing with multiplication, we are going to add. So let's have the direct opposite of that. So this is going to be a to the power m minus n. Whenever that we are dividing and the bases are the same. Also remember, a cannot be equal to 0. Okay, so it's easy there. Let's have raising a power to a power. So let's have our law number 4. So from here, I want you to take a little bit of care with these ones, because these are the ones that we're going to use mostly in questions, especially in grade 10 to grade 12. So this one says a to the power m raised to the power n. This one, it's simple. Power raised to another power, they simply multiply. Okay, so we're going to have a to the power m n. So those two, they're going to multiply. It's easy. And remember also that a has to be smaller or greater than 0. It has to be smaller or greater than 0. A is not equal to 0 in any of this. Okay, remember, if it becomes 0, when you raise to a power, that number is going to be undefined. Okay, for example, let's have an example. If I have, say, 2 to the power 2 raised to the power 3. It's easy. I know I can simplify this using the fourth rule or the fourth law. 2 to the power 2 times 3, which is going to give me 2 to the power 6. Okay, so raising a product to a power, that is going to be our fifth law. So in this one, we are having a, remember we are raising a product to a power a times, let's say it's a b there, to the power m. This is easy. Using the same rules, remember the m, the power is affecting everything inside the bracket. So when we're going to simplify, always remember that this m is not affecting b or a only. It's affecting everything that is inside the bracket. So when you simplify, this is going to be a to the power m multiplied by b to the power m. And always remember that a is greater or smaller than 0. M and n have to be whole numbers. We sometimes calculate with this law. How can we do that? Sometimes you notice that I'm going to have, say, this a, I'm going to have it as, say, a to the power m and multiplied by b. Okay, so if I have this, I can now raise this to the power, let's say, n. So I can play around with this. Remember, this is affecting everything that is inside the bracket. So if I'm now going to multiply, remember on A, there is M